let's design a service that is averaging the stock or token price coming from various exchanges every 10 seconds, right? Maybe let's say the prices are coming from various exchanges every 2 seconds, right? Let's say there is a different prices. Every exchange is kind of pushing the price, or the prices are changing for a particular token every 2 seconds. And what this service or the dashboard that we want to create is that should kind of average, take an average of the stock price and push it every 10 seconds, right? So let's quickly go through the functional requirement, what it would be. Functional requirement. Let's say the first one would be whatever is there, like takes the system takes all the prices for each token. The second thing could be where on the dashboard users could see the price of a particular token as a chart, right? Or point in time data would also be available. These are like, okay, on the dashboard we should see the updated values for all the tokens that are there, and the thing is like the values should be averaged. Coming to the non-functional requirements, so the non-functional requirements that I can think of is one, definitely it should be scalable. Basically should handle the burst of traffic. Like sometimes what may happen is like some of the tokens or new tokens that are getting added, or somehow there is more what do you say, activity that is happening on certain tokens or the stocks. But here we can see like every 2 seconds the exchanges are sending the data. But again, like there could be a new exchange comes up, or even like new tokens come up. How should we handle the scalability part? Similarly, the system should be available also, right? Available, that is user is able to see the stock prices, right? Right, this is there. uh, and then should be quick, that we have already given, which is like 10-second time interval is already there. But in these 10 seconds there could be like thousands and thousands of tokens could be there. Should handle and update the prices, average price for all the stocks for, let's say, 100k tokens, right? So you can see like number of tokens and all of those things that are there. So what it would mean is like it's a high traffic system that is there. For these kind of projects, like the problems, one of the things like the estimations and all of those things could be done. But as we already know, like this is a very highly available system. Sorry, it's a high traffic system. So we have to build a highly scalable system. Even if we calculate like do the estimations, figure out what would be the RPS and all of those things, uh, right? I mean, then also it is not giving us much. So it might be a good idea to kind of skip that in the starting. You can tell the interviewer like, okay, as in when you will need it, you will kind of send it, or like you will calculate this thing, right? But for this particular problem, I think one of the things that you should clearly call out is kind of the number of updates that might come, updates that can come per second, right? So let's say if there are 100k tokens, which is very less though, could be even more a number of tokens, right? And then there are, let's say, the 10 or 20, let's say the 10 exchanges that are there, right? Exchanges. So basically that would mean like 100 into 10. That becomes basically a million, 1 million per 2 seconds. So roughly around 500k uh, token updates are coming in, right? Or you can say this is the TPS that is there, right? This will give you some idea. Cool. Now how we can kind of go about building this. This is one of those services, or like the question where you don't really have to build the APIs, because this is not more of a product facing rather than more of an infra heavy thing. So what, let's just put a quick high level design, and then we'll go on to like what could be done, right? So one of the thing, I mean, by this time you would have understood, like there is a, I mean, this seems to be a problem that is more of a stream processing kind of a system. So let's just quickly put together somehow like these exchanges are there. Here it's better to clarify like whether you want like whether it's a push based or a pull based thing, because that would depend like how we are running these. But for now, let's just assume like this is all of these exchanges are kind of pushing their events, and we have a, let's say, a queue that is there. We'll have a queue, and what I'm kind of thinking here is, let's say we'll have a, we'll put a stream. I mean, this queue could be Kafka or even like Kinesis, right? This is maybe like the stream processor. Either we can use Kafka stream processing, or for here I would be using Apache Flink. The major reason is because I'm slightly more familiar with the Flink. What it does is it kind of the exchanges are pushing to the queue. I mean, we'll kind of come back here. What we want to do, we kind of, there is a queue, like all the events are kind of going in here, and then there is a Apache Flink that we have added. That Flink is kind of pushing the data into a time series based data, because that's our first requirement, right? Let's say this is our time series data, time series DB, right? This is where we are pushing, and on top of it probably there could be a, sorry, we can kind of have a, let's say the, somewhere load balancer is here, right? This kind of goes to the, call it a dashboard service, right, which has the APIs and all of those things, and those are kind of making a call to this time series DB. This is how the flow would look like. What this mean here is, let's say the token, let's say the token T1 uh, price was like X, maybe like $2. Then this is at the time T1. Similarly at T2, probably like $2.1, right? T3 is $2.2 or something of that sort, right? That's how the various data would be coming in from these exchanges. Various exchanges are kind of pushing this thing. So what's happening here is like this, at Flink basically we can have a 10-second flush interval, like 10-second, or call it a aggregator time. So what it will do is it will kind of aggregate and then push the data into the time series DB. Right, it will take the average, it will push it. Right. So now, as you can see here, like this will have the data, which is the stock price, right? Which will have the token timestamp, and probably and then the price. These are the three things that are there. This will be one table that we'll be having. Again, like we are not yet going into the partitioning and all of those things, but these are the APIs. Let's say the uh, get price, right? Let's say token. This is what it will be like. Let's say the get price API, that would be called, and this will go here like the dashboard service. Uh, all of these are kind of distributed service so that the load can be handled. But as you can see here, like this majority of the, I mean, this would be the API traffic that is here, probably like wherever the user is, right? Whatever the UI that is there, it will kind of fetch the data from the time series DB. But majority of the work would be here, because these exchanges are kind of sending the data like close to 500,000 requests per second. That's the kind of request that is there. Like these exchanges are there. One approach could be like if it is more around like we can't directly expose the Kafka or the Kinesis queue here. So I would say like there is a, let's say in between there is a service which we'll have call it a okay. So this what I kind of want to do is instead of exposing the queue directly, there is a this service that is there, which is kind of, let's call it price fetching service. There could be like multiple versions of that. One could be like where there is some way of uh, what this does is it has two things. One like either two approaches, workers to pull the data from various exchanges, pull based, or API exposed the API that the exchanges are calling to publish the price, right? And this is a basically a stateless API. What it does is basically like this API would kind of write it into this service. Let me just move it slightly here. Okay, token T2, like this is what is happening, like all of this. This again, like as you can clarify, as you clarify, there could be like pull or pull push based. This data you can assume like this is the data that is already coming. Now, what happens here is like this service is kind of pushing the message to queue, right? And this goes into Kafka Apache Flink, which is doing the aggregation and pushing it to the time series database. So this will have like at the interval of 10 seconds. So like first 10-second interval, then second 10-second interval, and all of those things that would be here. For now, the assumption is like this is running like 24 by 7. There could be like sometimes there could be more number of data, sometimes there could be lesser data, and all of those things. But this is what it is. So this kind of, let's go through the functional requirements first. Like this is the initial flow. That's what it looks like. System takes all the prices for each token, average it, and make it available. That's what is happening. Time series DB that is here. On the dashboard, user could see the price of particular token as a chart. We have an API here that is a load balancer. This dashboard service is there, which is just talking to the time series DB. This could be any influx DB or anything. Right, it's getting from there. Right now, there is only one primary DB. Point in time data should also be available. I think get price that gets the range queries and also the point in time data, which is basically for the current time, right? So this is what the functional requirements are kind of fixed. Now come to the non-functional requirements. As you can see, like as there, the TPS is 500,000 updates that are happening, right, on an average. So there'll be like 500,000 messages that would be pushed to this particular queue. So the one of the thing, for example, let's take the Kinesis for now here. Could be Kafka also. Let's say Kinesis, what we'll do is we'll kind of partition it, or like create the topics for each token or stock. Basically what this would do is like this will help us, like all the updates would go to individual topics, and Apache Flink also we can kind of partition it based on the token, right? So that like the aggregator that is there, it is kind of doing the aggregators, and that way like both of these becomes like horizontally scalable. In the Kinesis, basically we'll have or even in the Kafka, the topics are based on the token. Each token has a topic, and after that it will be yeah. So this is horizontally scalable. Apache Flink is also what do you say, the horizontally scalable because it is handling the party based on the partitions, and partitions are nothing but the topics. So we can kind of keep on adding more and more workers. So Apache Flink is reasonably horizontally scalable, right? So this is kind of handling the 500,000 TPS. This is also handling that. This service, like, because the EPAs are more stateless, so we'll be having like lot many instances of that, and the only thing that the EPA is doing is kind of just putting it into the Kinesis. Why we have kind of done this is to make sure that they're not directly like all the exchanges don't really have to talk to the queue directly, rather than they can be basically like this simple service that is there. Right now, as the data, what would be happening here is like the 10-second aggregator is we are doing the 10-second aggregation, like the our uh, aggregation window is 10 seconds. So this will kind of create the T1, like for the, let's say, the first 10 seconds, it will kind of keep the for the token T1, what is the average price, right? That's what it will kind of keep on doing in the memory. Similarly for the T2, here like the workers not only for like one worker or like one Flink instance for like one token, rather than we can have like a worker handling like pool of topics and all of those things, so that we can quick leverage all the resources that are there, right? But what the Flink does is basically it kind of stores the data uh, in memory, and then as the 10 seconds are coming in, it will kind of flush it or like write it to the time series DB that is there. Right. So this is there. The other few more things that Flink has is kind of you can first is 10 second, right? But there are few other things, like basically you can put like flush interval also, which is basically what I'll try to do is, let's say if we keep a flush interval of 5 seconds, though it is doing the aggregations at the 10 seconds, but by the 5 second, whatever the data that it has, it will kind of go and flush it into the DB. That way we'll have the partial data here. And yeah, and at the 10 second, we'll get the data. So at the 5 second, some of the data could be inconsistent, like some half data would be there, but it can give you some idea about like how the price is moving, because the 10 second is likely more. You can kind of here you can see like you can scale it up, like reduce the time also. If it is coming at 2 seconds, then probably like you keep it at like 4 seconds or something. Your number of what do you say, the instances would increase, or like the flush intervals would increase. The number of writes that would happen in the time series DB, they'll increase, right? But it kind of takes care of that issue of like what happens if the Apache Flink instance goes down, because all of this is in the memory. One of the problem like ways how you kind of handle that uh, issue, like what happens if the your Apache Flink instance has the worker that was handling that goes down, and somehow your data is not available for that 10 second. One of the suggestion that people give is like we can ask the Apache Flink to dump the data into S3 and all of those things so that it can recover. That is fine, like theoretically that is fine, but here I would say like because our aggregation window is too small, like it's just 10 seconds, so I wouldn't kind of suggest that we dump it into S3 from Flink. Rather than what we could do is like whatever the data that is not processed, it will anyway be here in the Kinesis. What we can have is Kinesis or Kafka, we can have like the retention policy. Retention for the messages could be, let's say, the 7 days or something, so that if some of the instances have gone down here, like whatever the workers that were getting processed, we are repurposing it from the Kinesis itself, so that we don't really need the Apache Flink to dump it into S3 and recover from there. Had it been the time interval, had it been like maybe like a day, half a day, or like maybe an hour or 2 hour, in that case, I would have suggested to put it in the S3 by the time of whatever it has done. But I think this flush interval would kind of help us, so that whatever is the last one, we can calculate that itself, right? Here, so that is one of the deep dive. Here on the time series DB, like one thing that I haven't done is kind of there is a, we can have like read replicas also here. Like there is one, right? Uh, and then there are multiple read replicas that we can have. And that is basically based on the traffic that this service dashboard service is having. I'll not go much into detail, but basically the data would be pushed from here, and this will be quite scalable. That we can take any of the existing time series database like InfluxDB, or even like build it on top of the column, like key value, or the column database like Cassandra and all, which are very easy to kind of do that. Or like here itself, because some of the time series databases, they can have some other type of aggregators also, or we can build those aggregators here if we want them in the real time, right? So this is their Kinesis. We have done that. The other issue that would come at the uh, another issue that can come in for the or where you like, especially the senior engineers can show their seniority, is basically going into some of the areas. One of the problem that could be there, which is the hot topics, or like hot shards that would be created here. Let's say if there is a somehow a new token came in, right, and somehow there is a lot more activity that is happening on that, though all the exchanges are kind of sending the requests at every 2 seconds, but there are a lot many requests that are coming in. How to handle that is basically kind of we can create the like here the shards or the topics that are there, right? In Kinesis it will be shards, or in the top, like whenever we are having the topics or the partitions, what we can have is like in the shards we can add, let's say, the token and probably a random number, some number, right? Could be, let's say, 1 to 10, right? Or 0 to 9. So that means like there is a one topic, but it has been converted into like there are 9 or 10 different charts that are there, so that this is scaling, and the one single topic is, or one single chart is not hot enough. And Apache Flink would still be handling, like there could be the grouping that would still be there. It will be handling those messages that are coming in on all of these different charts in Kinesis, and then it will be aggregating and storing it here, right? So that's how you can kind of handle the Kinesis, and this is the service that would kind of make sure that like handles the hot shards case by creating multiple shards, right? So this is what it will do. Like this service would create those topics and whatnot whenever it got in the data first, right? So this is what the Kinesis. This is how we can handle it. This will be quite horizontally scalable. We are doing the aggregation at 10 seconds. The flash interval is 5 seconds. So the data would be available for every 5 seconds. In the worst case, by 10 seconds, if something goes down, we'll rely on the retention of the messages. The workers would go again and they'll process it again and publish it to the time series DB. If there is another kind of, let's say the aggregations are required somehow, or like some reconciliation is required for some reason, what we can do is kind of push it to S3 here, right? Flink provides the S3 dump. Either we can have it, or like even from in the Kinesis, from Kinesis we can put it into the S3. And then here there could be like probably let's say there could be a Spark, right? Spark MapReduce, right? For the to run the Spark, we'll have to have some cron schedulers. So there'll be cron. This kind of gets the data from here, right? And then kind of pushes here, or there could be like another. Let's just let me just put it here, right? Other aggregators, or maybe let's just kind of, if anything else that needs to happen, call it a reconciliation. Reconciliation, and then it will kind of push it here, right? If something is incorrect and all of those things, like current price and all of those things, though there could be some incorrectness, but this is more around at the end of the day, or maybe something of that sort. Anything else that it needs to push, either this could be done on this data that is already available here, or if you want to do that processing, this is more of a offline processing, right? And this is more of your online, or like the real-time processing. So this is how the system would look like. Now going back to the non-functional requirements. We can, I think, handle all of them. Even if 100k tokens are there, this write would handle. We can have multiple instances and all of those things. By creating the read replicas, we can handle all the prices and everything. I haven't talked about the cache and all of those things, but we can kind of add it here. Or even like some of the other aggregators could be added, which could be either come from the offline processing of the Spark jobs and all of those things. We will dump it here after the reconciliation because this knows data better. So it will just update the existing records and everything. This is the, I hope this makes sense. Yeah. So this is more of a stream processing question. Great. Again, if you like the video, or like if you like these kind of sessions, uh, please like the video. Also, keep on commenting. What else would you want me to solve and record for you guys? I kind of try to take a more of an interview-like approach, where like how would you kind of discuss these kind of things in the interview, rather than teaching it on the slides or all of these things. I try to replicate the interview situation here while I'm recording the videos. Hope this is helpful.